In the coming decades, we will see a revolution in the way electricity is generated and stored.
We use theoretical, computational, and experimental approaches to study, improve, and invent systems for sustainable energy storage.
We're nano-engineers, material scientists, chemists, and microgrid experts.
We are leaders in electrical, structural, and chemical engineering, as well as the economics of renewable energy.
We're professors, students, and research scientists.
Together, we are the Sustainable Power and Energy Center at the University of California, San Diego.
Humankind has been burning stuff to generate electrons for almost 300 years. To combat climate change, we will have to decarbonize our electricity grid. Today, in the world, we do have a lot of wind and a lot of solar. The issue is that a lot of the electrons cannot reach the customers. They can't use it. So batteries will change that picture and solve that problem.
Here at the UCSD SPEC Center, we work on different type of materials, different type of chemistry, and different type of processes to design better material, to understand material better, and then come out with new solutions for next generation of energy storage and conversion.
I believe sustainable energy will be a core economic driver of the 21st century. For me, thinking of batteries as living systems is trying to diagnose, cure, and treat batteries the way we treat humans. So we place so much importance in human lives and place resources and investments to try to find the most elegant solution, the most elegant drug to treat humans the cheapest and the safest way. Why can't we do the same for batteries and all devices around us?
Lots of the out-of-box ideas come from the students who previously have not been exposed to the industry. And that's precisely the reason why they can come out with those kind of crazy ideas. So our job actually is to bring them back to the ground and then really think about what aspect of this crazy idea can actually be implementable. We do encourage the students to think about start up their own companies.
So I'm a founder at Unigrid along with several colleagues. Unigrid is a spin-off startup from SPEC Center, and we are trying to commercialize technologies that we developed there. One of these technologies is the sodium all solid-state battery. So there's no lithium in there, no rare elements in there. The idea is to enable its application for grid storage.
While we are doing our research on many of the forward-looking technologies, we always think about how that's going to impact the manufacturing sector and how can our students be the leaders in terms of the change that is going to come.
SPEC Center has partners with many energy companies, both within the region and the country and the world as well. And we get a lot of wonderful opportunities to work with them, to see what's really happening on the manufacturing side and how we can bridge what we built in the lab to the manufacturing scale.
Asia is the center of manufacturing. So when we come out with a new idea, a new technology, we have to think about large-scale manufacturing, and then our technology is very likely to be able to fit into the entire supply chain so that we can facilitate from our discovery to commercialization to real implementation of a large industry.
At the end of the day, talent determines the technology's future. Because of the climate change and all the big picture issues, if we decide to take action, we need to develop the talent for those emerging industries in clean energy.
I feel very grateful that more and more students are starting to choose this line as their possible choices of the subject.
You need to have a sense of passion, a sense of purpose. That will help you to drive your work. Researching these topic areas is not easy. And when you run into trouble, you need a purpose to drive you through. And that's probably more important than anything else.
UC San Diego is actually my first choice. They have one of the best STEM field research in the entire world, actually. UCSD also has a wide diversity of students, faculty, and people from all sorts of backgrounds and nationalities. I've experienced personally how this can directly contribute into innovative discoveries and breakthroughs.
I think there are major roles that the SPEC will play in the future to ensure that a significant amount of resources should be allocated to renewable energy and their deployment and their integration and their socio-economic impact.
We have to think of it on a bigger scale. We cannot make incremental improvements to existing technology. We have to take a big step.
The challenge is really immense. The problem is very hard, but we have some of the best minds coming to UCSD to pursue their degree, to work together in the SPEC Center platform where the students are encouraged to think outside the box.
The past 100 years, we've seen huge developments in food and water sustainability, and now it's up to our generation to do the same or better for sustainable energy.